Hello, everyone. In this podcast, we will be discussing sensitive topics such as sexual assault. It's important to take care of yourself while listening. Some suggestions are listening while you're in a healthy headspace or knowing who you can reach out to if you become upset. Our 24/7 helpline for crisis calls based out of Central Florida is 407-500-HEAL. By contacting the national hotline at 1-800-656-4673, you can get support and learn about your local resources. There's always someone ready to help.
Welcome to the Victim Service Center podcast. Here we sit down with professionals that serve survivors and victims of trauma or those who have experienced violence and have conversations about social issues. This week, we are talking about forensics and sexual violence, research and the future of DNA evidence collection. My name is Emilie Mitchell. My pronouns are she, her, and I am the education coordinator at the Victim Service Center. With me today, I have Dr. Jack Ballantyne. Jack uses he, him pronouns and is a professor of chemistry at the University of Central Florida and an associate director of the National Center for Forensic Science in Orlando, Florida. Prior to entering academia, he was a casework forensic scientist in Scotland, Hong Kong, and New York. His current research projects include the use of Y chromosome markers for sexual assault investigations, RNA profiling for body fluid and tissue identification, trace DNA analysis, including single-cell genomics, and mixture deconvolution. Jack, thank you so much for being here today.
You're welcome. It's a pleasure to be here.
We are so excited to have you come on the podcast and share a lot of your knowledge. So thank you once again. And also I have returning Dr. Erin Hanson. Erin uses she, her pronouns and is a UCF Research Associate Professor in the Biological Evidence section of the National Center for Forensic Science at the University of Central Florida. She has volunteered with the VSC 2018. So Erin, thank you as well for coming back onto the show. We're excited to have you here too.
I'm excited to be back.
Awesome. And I'm really excited to have this really important discussion. I feel like it's long overdue. We're pretty far into the podcast and we haven't even talked about forensics. But as a brief introduction, as a certified rape crisis center for Orange, Seminole, and Osceola County, one of the free services that the Victim Service Center provides to victims and survivors of sexual violence is DNA evidence collection. We previously had an episode speaking with the same nurses that collect that evidence, but this week we have two amazing researchers from the University of Central Florida here to talk about their work in the lab, the science behind DNA evidence collection in sexual assault cases, and the future of forensics and sexual violence. So with that in mind, either of you can start, but could you both talk a little bit about your backgrounds and how you came to work at UCF?
So I'll start with my background. It's not an overly exciting background, but when I was in high school, I knew I was coming to UCF and I flipped through a catalog and said, what major can I pick? And I found forensic science. So it had all the classes that I was interested in, all the science classes, but it was an applied field that had a defined career path, and that really appealed to me. So I started forensic science on day one, and I've been here ever since. So I've been a student, a graduate student, a scientist, and now a faculty member here at UCF. And I've worked with Jack on forensic science research for almost 20 years now. So we've had that great opportunity to kind of do some very exciting research together.
That's incredible. So 20 years that you've worked together?
Almost. I think next year it'll be close to 20 years.
How time flies.
Definitely. Jack, could you go in a little bit how you found yourself to work at the UCF?
Yes. Well, I've been at UCF for 22 years. But before that, I spent almost 20 years in industry as a caseworking forensic scientist in the UK, Hong Kong, and New York. Before that, I was a police officer, actually, on the beat in the United Kingdom, and then an inspector of police in Hong Kong as a uniformed supervisor. So I was in the police first before becoming a forensic scientist. My casework industrial experience, that's my casework experience, it means that I attended crime scenes, examined physical evidence in a lab, wrote reports, and gave evidence in court. I finished my PhD in genetics as a mature student while working as a forensic scientist. I believe that in my casework days, as it pertains to this particular podcast, I was responsible for the analysis and interpretation of thousands of sexual assault cases. So I decided to enter academia, however, at UCF in order to do research in forensic science to help develop better methods for forensic analysis, including in sexual assaults, and of course to help educate the next generation of forensic scientists. So that's my background.
Thank you so much for going over that. That's amazing. And thank you both for all of the work that you do. It's really, really important stuff. And I'm just really grateful that you all have done so much in the work in regards to sexual violence and DNA evidence collection. So thank you so much. I wanted to first start off, Jack, could you explain a little bit about how DNA evidence specifically in sexual assault cases is analyzed?
Yeah, basically we can use DNA typing to identify an individual of interest who transfers biological evidence from him or her to another person or object. So during a violent crime such as sexual assault or homicide, a transfer of blood and other body fluids such as semen and saliva is often transferred. In a sexual assault case involving a female victim and a male assailant, which is unfortunately the most likely scenario, the physical evidence recovered include intimate swabs taken from the victim. What I mean by intimate swabs is, for example, vaginal, anal, or oral swabs, depending upon the circumstances of the assault, and any items of clothing or bedding, etc., that may be pertinent to the circumstances. So DNA is found in these body fluids and can be extracted and analysed. So for standard DNA analysis, one that is called autosomal STR analysis, technically, it's called autosomal STR analysis. That's standard DNA method used by all the laboratories in the United States. The DNA of each individual is unique, with the exception of identical, that is monozygotic twins. So if you look around you, each person's face is unique, and that is because most of the variation in faces is genetic in nature. Compare that to identical twins. They look alike because the DNA is the same. So basically DNA is unique between individuals. We can uniquely identify an individual by the DNA testing. So basically we extract the DNA from the semen, for example, found in the vaginal swabs and obtain a DNA profile. And that DNA profile is then compared to the DNA profile from the victim and the suspect. And then that suspect is either included, that is, he matches, or is excluded. And that's an important aspect of our work. So to include or even exclude falsely accused individuals. So the crime scene profile then that we obtain, meaning from the vaginal swab, for example, is also searched against a national database to see whether it matches any individual or in the database or whether it links to another crime. So basically that's the gist of what we do in terms of sexual assault DNA evidence.
Got it. That makes a lot of sense, and thank you so much for breaking that down. So it sounds like you take the DNA evidence and then you try to match it to see if it's the person. You match it against the national profiles as well. So there's two steps.
Yes, because obviously, if you have a identified suspect, we can compare that DNA profile to that suspect individually, no problem. And if it's a non-match, meaning he's excluded, we will then look at the national database. But even if it's a match to that individual, we will still look into the national database. Why? Because in that database we have other cases that have been committed, so we look for that.
We know at the VSC a lot of times perpetrators are perpetrators multiple times too, so it would make sense if there are other crimes also connected to that person. So thank you for breaking that down. Erin, Dr. Ballantyne just described the use of autosomal STR analysis, known as the gold standard in DNA analysis. So what is Y chromosome DNA analysis, and how could this help in sexual assault investigations?
The standard practice that Jack just described involves autosomal STR analysis, so not any of the sex chromosomes, the X or Y chromosome. The standard process that we use and that crime labs use to analyze that type of evidence involves what's known as a differential extraction. And during that process, we are trying to separate sperm cells from non-sperm cells. Because when you're collecting these intimate samples, that we described in these sexual assault evidence kits, there's a large amount of female DNA compared to a very small amount of male DNA that might be there. So by separating out the sperm cells from the rest of the cells in the sample, we can kind of isolate that male DNA and get a better profile from the perpetrator. In a lot of cases, or a lot of situations, that separation process isn't possible or it will fail. And you end up recovering the male DNA still amongst that female DNA, that really large amount of female DNA. So if you tried to perform the autosomal STR testing, which is the gold standard, you'd either get a mixture, or because of how much female DNA is there, it would just mask the male profile altogether. So one solution that is available to labs in these types of situations is to look at Y chromosome analysis. And that's specifically, a male chromosome and a female would not have the Y chromosome markers. So you can go into a mixed sample that even has a huge amount of female DNA and still target just that male DNA portion in there. So it allows us to still detect male DNA in situations where that might not have been possible using standard analysis. So it's been a very, very helpful tool in sexual assault analysis because of that large amount of female DNA and the small amount of male DNA that's present.
Understood. Okay. And I wanted to ask, so it seems like that would help a lot for a male perpetrator and a female victim in regards to that DNA analysis. Do you find it difficult if it's, for example, a male perpetrator and a male victim? Then it sounds like that wouldn't work for that kind of case. Is that right?
It depends on the circumstances. So if seminal fluid was involved or semen was involved from both of those perpetrators, then it would both of their DNA profiles would be in that sperm fraction. But if you had one male assaulting another one and it was just their semen, then that process would still work because the victim would still just be epithelial cells, and that process would still allow you to separate the cell types. So you may be able to distinguish the profiles, but both males could be typed with the YSTR analysis and still get a profile. And if you had a reference sample from both individuals, then you could still use that. So it's still useful in those cases as well.
Got it. Thank you so much for breaking that down. So Jack, now that we've discussed the types of DNA profiles that can be obtained, does having these DNA profiles make it more likely to get a conviction?
Yes, if the DNA matches, then it will be used either in court in front of a jury or used by the prosecution to try and obtain a plea bargain. Nowadays, there's an expectation that DNA will be done in every case, and if it isn't, questions are asked. And this is really a cultural thing now. It's basically come into our culture as a result of this so-called CSI effect. People expect now. They're more knowledgeable than they used to be. They expect DNA to be done in a case, and if, as I said, if it's not done, there will be questions asked. So, but the important thing that people have to realize is that DNA itself cannot prove someone's innocence or guilt. So let me explain what I mean by that. And this is an important consideration for all sexual assaults, and sometimes it is forgotten. But basically, so let's assume then in a case a woman, a victim is raped by an individual. So that woman, the victim, is raped by an individual, and that's the perpetrator, the person committing the crime. But shortly before this, she's had intercourse with her husband or boyfriend. So basically, this woman was raped. It's a fact. There's a perpetrator. But prior to this, maybe within 24 hours or so, she had consensual intercourse with a boyfriend or husband. So this is what we've always got to realize, that before we perform the genetic analysis, this is what actually might come out of the analysis before we've even started. Semen, and they're all mutually exclusive scenarios. One, the semen we find, the genetic material, may only have come from the perpetrator. That's one possibility. Or the second possibility is that the semen may only have come from the boyfriend. Now remember, I'm talking about what actually happened. She was raped and the boyfriend did have sexual intercourse. But I'm telling you what, in terms of what the results could be. So that's the second one. The third one, the semen may comprise a mixture of semen from the perpetrator and the boyfriend. Or lastly, semen may not even be present, right? Despite the fact that these acts did occur. So knowing all this, when we get a DNA result, we have to say that basically the absence of semen from the perpetrator does not mean that he did not rape the victim, and semen from the perpetrator does not prove he actually raped the victim, because it could be consensual or But obviously, if it's definitively determined that no, it was not consensual, then that could prove that sexual intercourse took place. But nevertheless, DNA typically does not prove innocence or guilt. It supports a hypothesis. Certainly you can exclude people easily as being the donor of the semen, and certainly you can include individuals as being the donor of the semen with a high degree of probability, almost certainty. But in terms of the guilt or innocence, it requires other considerations. So that's a very important thing we have to realize in all of our DNA analysis, that it provides support for a particular hypothesis. It doesn't prove innocence or guilt.
It's interesting, though, that you bring up that it seems like the DNA evidence collection, it almost is expected at this point, right, in most cases. And so it needs to almost be there. But again, it won't prove innocence or guilty, like you were mentioning. It just adds to the evidence that is adding to the rest of the trial, or the other evidence is stacking onto it. So that makes a lot of sense. Do you find that a lot of people have that misconception, Jack, that you have to kind of explain that a lot?
Yes, many people, some deliberately will use this, because basically in my own experience, I've analyzed many cases where we've found semen that did not come from the suspect. That means the person was not involved. And then we find, of course, it's from a consensual partner. But sometimes the consensual partner is not known, or the victim is not, there's no necessity to describe who a consensual partner is. And so under these types of circumstances, you can make a lot of play on the fact, okay, this person is not linked to the crime. So it's a double-edged sword. DNA is very powerful evidence, but it can also work against the victim under certain circumstances. So that's why we have to be aware that basically the absence of semen from that perpetrator does not mean that he did not rape that person.
Got it. And do you find that this is specific in the terms of this misconception that DNA evidence proves or disproves its guilt, which we've broken down now together? Do you find that this misconception is specific for sexual violence cases, or do you find it for all kind of crime that this is a misconception that people have?
No, it's particular. This is a particular to sexual assault cases, because, and when I say sexual assault cases, I'm talking about intimate swabs. For example, the most common one, a vaginal swab taken after the incident, after the victim reports the incident. That is analyzed routinely, and you find a profile. If you find a DNA profile in there, that's consistent with sexual intercourse with that individual. And so it's very, and of course that is where, because obviously finding semen in the vaginal vault is good evidence of sexual activity as opposed to social activity, because often in other cases not involving sexual assault, you can say, well, this DNA got there because of passive social contact. It's hard to argue that in a vaginal sample, and so therefore it becomes more precise, and therefore there's a lot of attention played to try and downplay the evidence. For example, if you're the defense, that type of thing, and that's the normal. I mean, challenging hypotheses is a normal part of the scientific process and the legal process. It's not a problem, but nevertheless, we always have to be aware that not finding the semen from the perpetrator does not mean he did not actually rape that individual. That's the most important factor. Now, there are certain cases, extreme cases, maybe involving young children, etc., whereby, the DNA itself can prove with a high degree of, with a high degree of probability that this incident took place. But in general, we always have to be very well aware of these factors that are out with our control. It's basically what happened in the incident, and we don't know until we've analysed the evidence whether or not it pertains in this case. Obviously, if you find DNA from the perpetrator, then he has got to explain that. If it's explicable as a consensual, then that has to play out, and whether or not that's true or not will be investigated. So we just have to look at different scenarios and be aware that different scenarios can result in the same DNA evidence.
And I think that speaks to another reason why these challenges are specific to sexual assault evidence, because if you think about it, it used to be people would challenge the presence of their DNA being there, but now most people accept, okay, if my DNA is there, I've got to come up with some other explanation for why it's there. And in sexual assault cases, that usually transitions to it's a consent issue, and the perpetrator will say it was consensual, and then it falls on the victim to kind of, prove almost that it wasn't. So that to me is unique in sexual assault evidence, where in other type of crimes, that's not necessarily challenged as much. If you find someone's DNA there, they were involved in the crime, whereas sexual assault, you get that chance for victims to kind of be, put in that position of having to explain that, and it's a he said she said situation a lot of times, and it's very unfortunate, and that makes it unique to these type of cases, because in most other ones that challenge isn't there. But in sexual assaults, there's always that possibility that it was a consensual act, and unless you were there to witness the act, it becomes the testimony of those two individuals, and it's really difficult sometimes, even with DNA being there, because this shift has happened where we can accept DNA results, but now it's the job of attorneys and people to explain why it's there. And so you have that kind of situation in sexual assault evidence where you can have that type of challenge to the events that might have happened.
Yeah, I think it's really important to highlight all of those amazing points, because it is complicated, and it just seems like it's a really difficult path sometimes going through the criminal justice system. But I really appreciate you highlighting, both of you, that. That being said, Erin, what is the time frame in which you can actually recover DNA evidence typically in sexual assault investigations? And are there things that can be done to better preserve biological evidence in these cases?
There's always going to be some variability when we talk about timeframes. So just in general terms, thinking about the standard DNA analysis, that autosomal STR analysis that Jack talked about in the beginning, usually in a 1 to 3 day time frame is when that analysis would be possible. And again, it all depends on many, many circumstances of the event and of the collection time interval and what the victim was doing afterwards. So there's all kinds of variability, but traditionally 1 to 3 days was kind of that typical evidence collection time. Now, because of the Y chromosome analysis that we talked about, we've seen an extension of that interval out to 5 days. So most jurisdictions have now extended that, and they'll collect evidence up to 5 days after an assault. So because we can go in there and specifically target that male DNA using Y chromosome analysis, that has really allowed that kind of extension in that longer period, because studies have shown that male DNA is still present there. And so it would have been almost negligent of us not to, use it now that Y chromosome analysis is possible. And so we've seen that extension out to 5 days, which is really promising. As far as things that can be done to better preserve it, I mean, the biggest thing that, you can do is get the evidence collected as soon as possible. The sooner it's collected, the more evidence would be there for collection. So that's one of the main things that someone can do. And then their own actions afterwards, not bathing, not showering, not douching, and things like that might remove potential evidence. That can help preserve it. And then, of course, in the evidence collection side, if we need to preserve that evidence once it's collected. So we need to store it properly, document it properly to make sure that the integrity of that evidence is preserved as well.
And the VSC, we do that the 5 days. We're able to do that as well and collect evidence up to 120 hours or 5 days from the assault. But you've been talking a lot about Y chromosomes and collecting evidence from semen and those kinds of things. Is it difficult to collect evidence if the perpetrator is female?
No, because depending on the circumstances of the case, then that basically informs us as to what evidence we're looking for. So depending on particular circumstances, it's not a problem in finding evidence if there's been a direct contact between two individuals, because in forensic science, there's a basic principle: every contact leaves a trace. So basically, when two people come together, one a perpetrator, one a victim, you can transfer biological evidence from the perpetrator to the victim and from the victim to the perpetrator. And we are in as forensic scientists, we're used to looking for that and finding the evidence. So if it's a female situation, of course, we're not looking for semen, but there are other body fluids, saliva, there's blood, of course, depending if it's an assault, there's touch, DNA evidence, there's if there's a vaginal assault, we can look for material from the vaginal canal because there's DNA present there. So it just depends on the nature of the assault. But finding evidence between two females is standard forensic work anyway, because we don't only deal in forensics with sexual assaults. We deal with all sorts of violent crimes and things of that nature. So we're used to looking for that type of evidence. So it just would be different. It would just be the body fluids would be different, perhaps, but nevertheless, we can normally, find evidence if it exists.
Okay, I appreciate you breaking that down. Thank you so much. By the way, Jack, Dr. Hanson described the time frame of sexual assault evidence collection being 5 days, like we were mentioning. So your research, from what I understand, is hoping to extend that interval. So can you describe your research and how you're working to do that?
Yeah, so obviously, for a variety of reasons, the victims of sexual assault sometimes don't report the incident till several days after the event. That's the issue. And in terms of the DNA evidence, as it pertains to retrieving it from postcoital samples, as Erin has said, it deteriorates over time. And so the sooner the victim comes forward, then the better likelihood of getting a good standard DNA evidence that can be used to associate someone with the crime or eliminate someone who's falsely accused. And as Erin said, typically 3 days for standard postcoital DNA autosomal analysis, with Y chromosome now 5 days. However, we know from the clinical literature on human fertility and reproductive health that sperm can be found longer than this. It can be found in the cervix 9 days or more. We know that just from non-forensic studies, from clinical world. And so the task for us in forensics is to be able to recover a DNA profile from such sperm, but the quantities are very, very low. So we then have to employ different methods to do this. So our research is concentrated on increasing the sensitivity of standard or even Y chromosome DNA analysis. So we're trying to increase that sensitivity. How do we detect very, very small numbers? Typically a DNA test, the minimum number of sperm required, 30 to 50, that sort of number of sperm. We're talking about 1, 2, 5, a small number of sperm. What can we do? So we're doing this now by what we call SMART, single cell analysis, where we seek out the individual sperm, recover them by micromanipulation, by physically removing them, or via a more advanced technique known as digital cell sorting, where we can move cells around on a digital platform and then transfer them into analysis tubes. We then perform, even if we have these sperm now, we have to perform enhanced DNA analysis using a number of tricks, molecular biology tricks of the trade, to retrieve the genetic information from the individual or small pools of cells. We can then perform, standard DNA analysis, meaning autosomal analysis, or Y chromosome analysis, and there may even be other next generation analysis methodologies that we can employ that I might refer to later. But basically, we might be able to use this methodology to determine what a person looks like, but that remains to be seen. But what we're trying in the short term is, can we retrieve the genetic profile, the DNA profile from semen donors greater than between 5 and 10 days, basically. And who knows, even beyond that, but right now, between 5 and 10 days. And we know that this is important because through drink or drugs or for other reasons, the person is known to, the perpetrator is known to the victim, or it could be a young child who didn't even realize what was happening. There is a certain percentage of cases. It's only a few percent of cases, but nevertheless, they're important cases, like they all are. So we're concentrating on trying to get information that otherwise, using other methods, would never be obtained.
That's incredible. That's basically doubling how much the time frame there. That's incredible work.
Yeah, we've been pretty successful with that. I mean, we've got published studies that show, using some of our techniques, that we can get DNA out to 9 days or possibly even longer. So we've been fortunate enough to do our own, small studies in our lab, but then also work collaboratively with other agencies to do a larger scale study to really demonstrate that that's possible. So we're hoping with work like ours and work that other people are doing to see that interval kind of get extended again beyond that 5 days.
Incredible. Well, thank you so much for all that you all do. I know that that'll make a huge difference for a lot of those survivors. And I want to uplift what you said, Jack, where you said, it might be a small amount of survivors, but every case is important. So I just want to uplift that, and I really appreciate that. Erin, I wanted to ask, how do you actually get samples for your research?
Through very willing participants. It's quite a process when you're talking about intimate samples, involving sexual intercourse. So we definitely go through an institutional review board policy where we have to have a human subjects protocol to ensure, health and safety of any participants, and also ensure their privacy. So any of the samples that we collect get de-identified so that they're not linked to individual people, and that's really, really important. In terms of finding participants to do it, we thankfully have a good network of people that obviously know about our research, know about what we're trying to do, or are involved in it themselves. And so we can reach out to these individuals and ask them if they're willing to participate and donate samples. So usually if people are involved in science, or they're involved somehow with sexual assault, in any way, they're pretty eager to help because they know the importance of it and they understand that, and they're willing to follow some of the protocols, which are, when you're talking about some of the swabs that we collect for this type of analysis, it becomes quite a lengthy process because what ends up happening is the participants have to abstain from any kind of activity or intercourse for a week or more prior to collecting the samples to make sure there's no residual male DNA in there. Then they perform their act of whatever activity we've asked them to do, and then they have to wait a defined amount of period until we have them collect that evidence. So we will ask them a day after intercourse up to 9 days after intercourse, and they can't have any activity in between there to really ensure that we're getting the most accurate or representative samples that we can to simulate these type of evidence samples. So it becomes difficult for people because there's large periods where there can't be any activity, and so a lot of participants don't want to abstain for that long. So it does become difficult, but I think we really try to find participants that understand the importance of that, and will follow that protocol so that we really get kind of true and accurate samples. So yeah, we're lucky in that sense. I think anyone who is a friend or a family member of a forensic scientist is kind of used to getting a request for their body fluids. My mom likes to joke that I travel around with swabs everywhere, and everybody is fair game that I come into contact with in terms of asking for body fluids. So it really, I think people understand the importance of what we do, and they're they're willing to kind of help us in that regard and collect samples. The intimate samples are a little bit more difficult because you've got two people involved and it's quite a process. But we've been very lucky to have people willing to participate in that.
Wow, that's a lot more involved than I thought it was, actually. So I appreciate you breaking that down. I also didn't even think about when we think about things like research, having it in the lab versus in real life, it's really hard to apply, right? And so I appreciate how real life examples that you're trying to get, but I didn't think of how difficult that would be. So everyone who's been, donating to your research, I just want to thank them specifically. I didn't realize how much of a process that would be. So that's really great that you have that circle of people that are donating their time and everything to that. Speaking of, those misconceptions that I was kind of talking about just now, what are some more common misconceptions regarding working in a forensic lab environment? So, for example, is DNA evidence collection similar to how it's depicted on shows like, SVU and other crime shows, or is there something the average person might not know that you'd like to share?
I mean, I think when you're talking about shows like CSI or, Law and Order, the concepts that they're talking about or the techniques that they're talking about usually are scientifically valid. They're things that we actually do. But of course, they package it into the 1 hour show where the criminal is always caught and it's some big, process that they've done and it works out every single time. So of course, that's somewhat misleading, and Jack kind of referred to this before, that juries see that and they think that every case can be solved like that, if there's DNA there, then it has to be worked out and you have to have a definitive understanding of what happened, and that's just not always the case. And then of course, if you don't have DNA, they have this conception in their head that every case should have it and you should find it, and that's the only thing that's going to solve this case. So it depends on someone's involvement with those type of shows. So there's good and bad to it. It does give that misperception to a lot of potential jurors, but then it's brought a lot of attention to the field itself. So a lot more people are interested in forensics because of shows like that. I think now, because forensics has become so popular, you have a lot more shows that go beyond those kind of primetime shows that are more true crime or forensic files or the Discovery ID channel, where they get more into the actual scientific accurate parts of it. They go through cases where it would be how this evidence played a part in it. So I think the growth of those type of shows kind of combats some of that CSI effect a little bit, because people get really into that and it's actual cases that they're talking about and actual evidence. And so I think that really makes a difference. It's definitely, I always tell people, day to day, it's not as glamorous as what you see on TV. So, you're just kind of working in a lab. We don't show up to crime scenes wearing high heels and no gloves or, some of the things that you see on TV. And it's a very stressful job. I mean, if you think about what forensic scientists are doing, they have a lot riding on the outcome of their work. These are people's lives, whether they go to prison, whether they're exonerated and things like that. So it's a little bit more stressful than I think most people think about. It's exciting, it's challenging, but it definitely, there's that component to it that if you're not prepared for, the stress and the seriousness of it, then you kind of have a rude awakening when you go to actually do some of this work.
I appreciate you bringing up that stress factor. I really did not think of that. And so how do you balance that stress in your day-to-day life?
I mean, I think at the end of the day, all forensic scientists have to keep in mind what they're doing it for. So you're doing this to aid in the resolution of criminal matters, whether that's, sending someone to jail that did something or exonerating someone that was accused of something that they didn't do. So day to day, that might get lost. But I think, when you are really stressed out, you kind of have to take a step back and know that that's what you're working towards. And for me, especially being involved with VSC, when you hear a victim speak about their story and even how, forensic evidence might have played a part in that, it really kind of brings you back to why you're doing this and why it's important and the impact that it'll have on someone. So I think whenever we kind of get stressed out, you just have to go back to why we're actually doing it and who we're trying to help. And that kind of gets you through, some of the stressful days.
I just want to thank you once again, because you both are definitely making an impact. And I'm sure that you've changed the lives of lots of survivors out there. So I just want to thank you once again. As a final question for both of you, where do you see DNA analysis and sexual assault research going in the future, and what research still needs to be done?
One of the things we need to do is to get results faster, because it takes a while for a DNA analysis method, for you to get the samples, perform the analysis, interpret the data, etc., and there are backlogs, etc. So we need to get results faster. That is why, to get the bad guys off the street, so-called, I'm using my police vernacular here, and eliminate falsely accused individuals. So there's a technique known as rapid DNA, and that's a technique that should be used. This is a new technique, which basically is a sample in, results out approach that gives a DNA profile in just over an hour. And we're going to see more of that and you probably see it in CSI and or Law and Order or something like that. Basically, people who will be arrested in booking stations, they'll give a sample, a swab sample, placed in an instrument, a button will be pressed, and a DNA profile will come out. That DNA profile will be then compared to active cases in the database, etc., etc. Right now, it's only being done for standard samples, reference samples from arrested individuals or convicted individuals, but arrestees mainly. But it will be applied in the crime scene investigation world. In other words, as it relates to sexual assaults, then vaginal swabs, etc. So, and it turns out that we, in fact, in our next phase of research, we will be doing some work in this area, rapid DNA. The idea is when the swab is taken, can we get a result within an hour, a couple of hours or so? So that's an important factor. So we're hoping to again contribute to this area. So that's one area. We need to basically get the results faster, so the results are actionable. So if you've got a suspect, okay, it now ties in with that suspect, clear. Or no, this suspect is excluded, then let's see if there's been another crime committed by the same individual, and also can you identify that individual using the database. So that's one area I see clearly is the speed. We need to improve the speed. Another area is cold cases, and what we mean by cold cases is a case where the victim has been, for example, sexually assaulted, but there's no suspect, there's no immediate suspect. So that's what we call a cold case in some ways. So these cold cases, of course, we can get a DNA profile from the sample, from her sample, and we can search a database. If there's no hit on that database, then it becomes truly cold. There's no genetic information, for example, leading to a lead. But basically, there are some methods now that we might be able to use in these cold cases that otherwise haven't been used up till now, and they're beginning to just gain traction. And one of these is called investigative genetic genealogy, and this sounds impressive, and it is pretty impressive, but basically this uses a much larger screen of genetic variants than employed with standard DNA analysis. But the point of doing that is to check whether by analyzing a larger proportion of the DNA in one's genome, which is the total DNA you have, to check whether anyone in genealogy consumer databases is distantly related to the perpetrator. And then if there is a hit, not a hit, but some potential leads there, potential relatives in these personal genomics consumer databases, then standard genealogy methods can be used to basically try and source all relatives from the person in the database who's not on the database, to then provide leads for the police to then investigate that individual. And then if they find out an individual who is potentially linked, they would then get that person's DNA and compare it to the DNA we got from the crime scene, from the rape swab, from the swab itself. So this investigative genetic genealogy is beginning to gain traction. It's been used for a number of of high-profile murder cases. However, there's no reason why it can't be used in rape cases as well, where there's an unknown perpetrator. So I think that is an important development that will be occurring soon. And then lastly, I would like to say another advanced technology is to develop what we call a genetic eyewitness. So by analyzing the DNA, other regions of the DNA, again, not the standard ones we use for identification, but we can infer what the person looks like, such as their biogeographical ancestry or ethnicity, their height, skin, hair and eye color, facial features, etc. These are genetic features that should be amenable. Some are right now, but some will be in the future amenable to genetic analysis. So basically, you've got an unknown perpetrator, and basically we can perform a genetic eyewitness to actually get. So it's instead of a direct eyewitness, you've got a genetic eyewitness with some of the physical characteristics of that individual, including the age of the individual as well, for example. So I think these are areas that we will see come in the next 5 years or so. I would predict, and we in this lab will try and participate, certainly in the rapid side, because it's a team effort, scientific effort. It's a global team effort. So we will be playing our part in some of these developments.
Yeah, I mean, something that kind of comes to my mind after listening to some of the stuff that Jack described is when you think about cold cases. For me, I'm hoping the science that we and other researchers are doing will support changes to, laws and evidence retention times and things. If you think about it now, there's statute of limitations on sexual assaults. Evidence isn't, stored indefinitely. And so some of these cases that had valuable evidence, we don't have that to go back to anymore and use some of these advanced techniques that may be discovered in the next couple years. So, when you think about all these cold cases that you hear about on the news, a lot of them are solved because now they can go back to evidence that was stored that had DNA present. And so it's unfortunate that sexual assaults don't usually get that same kind of advantage because the evidence isn't stored as long or the statute of limitations has expired. And so something that I would like to see, and I think with the momentum behind the awareness of sexual assaults and how big of a problem it is hopefully to change some of those so that we have that evidence there. Even if a victim doesn't want to come forward and prosecute, it's still collected and stored so that you can go back to some of these cases where standard analysis might not have worked and use some of these advanced techniques and, resolve some of these matters that otherwise would not have happened because the evidence just isn't there.
In 5 years, really? That seems like so soon that all this research will be. Do you think?
We're optimistic. We're optimists here. We have to be.
Yeah, that's completely fair. And I think that's wonderful to share. So thank you so much. But before we sign off, is there anything else you would like to address in regards to DNA evidence collection and sexual assault that we may have not covered so far?
The criminal justice, strongly we feel the following. The criminal justice system has failed many rape victims, really, because having a rape kit taken, which is a traumatic experience in itself, a rape kit, even the terminology is strange. Taking intimate samples from the victim is bad in itself. But when that rape evidence remains unexamined due to backlogs, this represents another form of victimization. So basically, all stakeholders in the criminal justice system, not just forensic scientists, but also forensic scientists, but law enforcement and prosecutors and politicians, right, need to work together to ensure that every victim who deserves justice or desires justice can and does receive a genetic test to try and identify the perpetrator. That's basically so. Trying to combine the timeliness aspect, making sure the evidence is looked at very quickly and doesn't get put into some backlog somewhere. That's going to be very important. And so every victim who's victimized deserves a genetic diagnosis. Basically, that's how we feel.
Yeah, and I appreciate you saying that the collecting the evidence itself is another traumatic experience that someone can go through, and they deserve that to be looked at. But so I think that that's a great place to sign off, actually. So I want to thank the listener for listening to the Victim Service Center podcast. The VSC is a nonprofit organization that provides free, confidential counseling services for victims of any kind of trauma in Central Florida. To learn more about our services, please visit victimservicecenter.org. To everyone listening, healing is not linear and you're not alone. And thank you so much, Dr. Erin and Dr. Jack, for being here today and sharing all of your wealth of knowledge. Thank you so much.
Thank you then, and goodbye.